Okay, Elenco Long Ranger LR-1 RF deck, which is part 2 of the walkthrough talk-through of the Elenco Long Ranger. I just did one on the power supply, and actually if you're gonna try to follow this walkthrough, do the power supply one first, and then once you kind of understand the power supply, which I just did, just dealing with the RF side of it. High voltage from the power supply comes in here. It goes, boy, my handwriting was really bad. I was tired when I did this. I'm tired now. But anyway, it goes through this plate choke, through the plate choke, through the parasitic suppressor, that's what that's supposed to be, and into the plate of the tube, right? Parasitic suppressors stop harmonics and parasitics from going through. It lets regular high frequency RF go through there, but higher harmonics and VHF don't like going through that choke, so it kind of blocks them out. That's the purpose of the parasitic suppressor. That choke there, again, it lets the high voltage DC in, because it'll go through that wire fine, but RF don't like going through a coil like that, so the RF is blocked as far as coming back through, but the DC can come in. So you got the DC going into the tube, and when the tube is conducting and has RF, it can go out, and it can't go through there, so it goes across through this capacitor, this plate blocking capacitor that does the opposite. It lets the RF through, where that lets the DC through, but this lets the RF through, but it blocks the DC. It blocks the DC. RF goes through the little small capacitor. The DC is blocked right there. Then over here to your tune and load and your tank coil there, your tank circuit. The tune and load on this are your little trim caps here on the side. Tune, load, like I said, they made this amplifier as cheap as possible. And then that's your tank coil there. This is that plate choke that lets the high voltage come through and blocks the RF from going back through there. They actually used a pill bottle. They took an empty pill bottle, and the cap is what they put the cap on the bottom and screwed it down with the cap and wrapped the wire around the pill bottle to make the RF choke. Again, why do they do that? Make it cheap as possible. Cost. These are the 4 parasitic suppressors going to the small tubes there. And then output goes over here to the relay, and when you key down the relay, the output goes out to the antenna. Also got a small cap that goes over to the output light, and that's this guy here. That's the small cap connected to the output over here, and then over to the light bulb there, and it lights the light when you have RF indicator light, right, for output. So moving right along, high voltage also not only goes to the plate. I said this amp is turbocharged. Got a 100 ohm resistor that also goes to pin 8 of all the tubes, and that's the screen. That's the turbocharge right there. Most better amps, you don't want to use the full high voltage potential going to the screen, because if you have the screen and the plate at the same voltage, sometimes the screen will pull too much or create too much power, and it'll pop the tube. That's not good. You usually want the screen significantly lower than the plate voltage. However, they built this amp cheap as possible, so they just threw a little 100 ohm resistor in there to drop the voltage a little bit. I mean, it works, but it's not effective. It's not great for longevity doing that. And that's that little 100 ohm resistor right there, tapped at that high voltage point coming in, and goes over to the screen of all the tubes. They're connected in parallel. right there. So moving right along, the cathode is grounded directly on it, and then grid 1, which is pin 2, that's where your drive comes in. And by the way, your bias from the power supply comes in going that way, and your RF from your input from your radio is going to come, when it's keyed down, this relay contact a key there, that's in the relay keys. It goes through this little blocking cap that again blocks that bias DC from going back into the radio and where it's not supposed to be, but it lets the RF go through. So the RF goes through here, meets the bias, and they both go up into the grid of the tube. That's grid driven right there. One problem with grid driven is that's a high impedance drive for grid driven. A grounded grid is usually low impedance, you know, like 100 ohms, 50 ohms, so it's already a good resistance for a radio to drive, and that's why grounded grid is a lot more common, because it's simpler. Anyway, because the impedance is high for the grid and the radio won't be able to take that, your input SWR would be sky high. Your radio's going to blow a final, it wouldn't drive it right, it wouldn't like it. What they did in this amp, instead of having a tuned input, they just use a 100 ohm 2-watt resistor right there. And that resistor is grounded also when you key the relay. This is the center contact of the relay here. And originally it just had this 100 ohm resistor, but with my 4 or 5 watt radio, I was getting too much drive and the input SWR was still a little high. So I added this, I believe that's a 82 ohm resistor also, not wire round. You don't want wire round because that interferes with the RF. So anyway, I put that on there to lower my drive a little bit and to get a better input SWR. But that's what that resistor does. And the guy is having problems with it, with his amp that asked me the questions in the first place. And he said he kind of got it going, but when he keys up, it chatters, you know, like it's, you know, yeah, like when you got it hooked up backwards. I have seen that problem quite a few times, and that's usually something is the matter with the input going into the tubes. Just like I was talking about, the input comes in, goes to the relay contact. If that relay's dirty and with it key down and that leg of the contact goes down and connects there, if that's dirty and not getting a good contact, your watts aren't going to go into the tube, and you're going to get a very, very high input SWR. And what happens is, here's the little sniffer for your keying tube, and everything is fine as long as your SWR is low. But if your SWR is high because this circuit is dirty because of that relay's dirty, or this 100 ohm resistor is bad or not wired right, or it's not getting the ground here, your input SWR is going to be sky high. So it's basically shutting off the watts from the radio. So when you key down, your radio watts get shut down, and since your watts are shut down, this tube is not going to see any watts going into it, the keying tube, so it's going to unkey. And as soon as it unkey, it's going to go back to the normal output until it keys down again. So it's going to key down because, you know, the watts are good going out, and then when it keys down, the watts are not going through, so it unkeys again, and that's how you get that chatter. It's like a loop of that, and most of the times it's a dirty relay, or since this one has a resistor, that resistor right there is open or bad or got a bad connection. that one that gives it a good input tuning. But anyway, it goes through the little cap and up into the grid. And then your keying relay is pretty simple. We got the grounded cathode tied to the input, goes around into both the grid 1 and grid 2. You got your high voltage here tapped, and that's your high voltage positive going into the relay contact. And then the negative side of that is grounded, goes up into the tube. So when you're not keyed up, you got, you know, the full high voltage there. But when you try to key up, the input watts, some of it go into the tube, a little bit of it, and the tube senses input, so the tube started conducting, and it basically connects the negative side of that high voltage to ground. It kind of grounds that out. And since this negative side is now grounded out somewhat, not totally grounded, but somewhat grounded out, the voltage drops. So you got full high voltage on that side, you got a lot of voltage drop on this side, and it keys the high voltage relay. Again, most problems with that are dirty relays and something wrong with the input SWR there. And every now and then you get a bad tube or a weak tube. It's usually not the relay. Relays get dirty, but usually they don't go bad. Usually. Once in a while, though, I have seen it. Anyway, I think I covered everything I wanted to cover on the Elenco Long Ranger. Pretty simple amp. Tetrode, so it's a modulator. But they built this thing cheap as possible. You can see it's not a lot of parts counts in it. Just your tank coils, your high voltage stuff, 2 lights, no meters, 4.6 GK6 tubes, keying tube, negative bias circuitry right there, basically this cap and this diode and your dropping resistors, high voltage caps, a tube for the high voltage rectifier, a dual diode tube, and that's about it, all to it. I added that big circuit breaker because I don't want to be running an amp with no fuse and no circuit breaker and no nothing to it. And a little modulator, did key about 20, swing to about 100 peak, and that's all it's designed to do. Alright, Elenco Long Ranger LR-1 walkthrough. Bye.